James Webb Space Telescope is a space telescope that was designed to study infrared astronomy in particular. The most powerful telescope ever launched into space, its greatly improved infrared resolutions and sensitivity will allow it to see objects that the Hubble Space Telescope can't see because they're too old, distant, or faint. The very edge of the universe will be one of the places where the space telescope will be pointed. The discovery at the universe's edge promises to be terrifying. What will the telescope see at the universe's edge? Will it be able to see the universe's edge? And how will this impact you personally? How capable is the James Webb Space Telescope now that it has arrived in orbit and work on getting up and running has begun? How powerful is this new space eye? According to NASA, the JWST is so sensitive to infrared light that it could detect even a bumblebee's slight heat from the moon's distance. To put it another way, this telescope is 100 times more powerful than the iconic Hubble telescope, which has been providing us with amazing images of the universe for over 3 decades. The JWST is designed to literally take baby pictures of the universe. The Hubble Space Telescope can take amazing pictures of space, but it has its limitations. It hasn't allowed scientists to see the first galaxies that formed after the Big Bang, for example. Webb will change all of that because it will act as a massive time machine. It's as if we have this 14 billion years old universe story, but the first chapter is missing. The JWST will capture light that has been traveling through space for up to 13.5 billion years, allowing us to see the universe hundreds of millions of years before Hubble. What it is about the Webb telescope that makes it so powerful? The 6.4 meter diameter primary mirror is the part of it. It is made up of 18 smaller segments that must be perfectly aligned. A single strand of human hair is 1,000 times thicker than the gold coating that covers the segment. 24-karat gold, which weigh less than 2 ounces, reflect infrared lights better than other metals. Infrared is just beyond what humans can see in the visible spectrum. The mirrors are actually made of beryllium rather than solid gold. The Webb telescope must be kept cool in order to function properly. A 5-layer sun shield the size of a tennis court allows it to do so. When Webb launched on Christmas Day, the mechanism was folded up, but the shield's extremely thin layer were successfully deployed less than 2 weeks later. The sun's immense heat would overwhelm the telescope sensors if it weren't for the shield. The side facing the sun will be around 260 degrees Fahrenheit, while the other side will be around 370 degrees below zero, a difference of nearly 600 degrees. Webb has a sun protection factor of 1 million thanks to the sun shield. One of the things that worry scientists about the Webb telescope is that they won't be able to correct any problems that arise during the launch and operation. In comparison, 5 space shuttle crews have visited Hubble during his lifetime to correct the telescope's initially blurry visions and perform maintenance and upgrades. However, this is due to Hubble's proximity of only 340 miles. The Webb telescope, which is nearly 1 million miles away, is much further away. This far beyond the repair capabilities of spacewalking crews. As a result, NASA only has one chance to get it right. If the right technology is developed, scientists may be able to send a robot to refuel Webb in the future, extending its life. When it comes to fuel, NASA originally estimated that the telescope would last only 10 years. But thanks to a successful launch, there's enough fuel left to keep the JWST running for another 20 years. For the time being, scientists are waiting for Webb's first photo, which are expected this summer. The JWST will then get down to business. It will aid in the investigations of the nature of dark energy in the universe, as well as the comprehensions of nature of these extremely ancient objects. It will also aid in the search for another Earth among many distant exoplanets that litter the cosmos. Surprisingly, even before taking its photos, the JWST began proving its worth, nearly $10 billion, because a precise mirror had never been created before. Northrop Grumman, which built the telescope's mirrors, had to break new ground. Eye surgeons are now using the technology that the company invented. They also work on computer-related projects. The company has made significant progress in understanding how to dispatch large objects, such as how we fold a giant sun shield the size of a tennis court and deploy it. What will astronomers see with the JWST when they try to see the edge of the universe? If you like what you see so far, make sure to subscribe to our channel to stay updated. Humans have always been curious about the worlds around them, but traveling across the universe involves not only traveling through space, but also traveling through time. Before we proceed, we must first establish something, the universe's dimensions, because in order to find the edge, we must first understand the universe's dimension. Our universe is estimated to be 13.772 billion years old, which is a very old age. So, just how big is our universe? Its width is estimated to be 28.5 gigaparsecs by scientists today. Understanding the magnitude of that figure necessitates a basic understanding of astronomical units. What is the size of a parsec? To comprehend how a parsec is defined, it is necessary to first comprehend what an astronomical unit or AU is. 1 AU is the average distance between the Sun and the Earth, which is roughly 150 million kilometers. As a result, a parsec is defined as the longest length of a triangle whose shortest side is 1 AU and whose opposite vertex subtends an angle of 1 arcsecond. If you do the math, 1 parsec equals 3.26 light years, or the distance light travels in a year, which approximately 9,460,000,000,000 kilometers. We are talking about 28 gigaparsecs, or 93 billion light years, or 879,780 times 10 raised to the power of 18 kilometers. That is unfathomably large. When all humans on Earth's DNA is stretched together, it will be about 0.119 billion light years long. Now, take a closer look at the figures from earlier, and you'll notice that something isn't quite right. Isn't the speed of light the absolute maximum speed that can be achieved? So, if the universe is 13.7 billion years old, how does it have a width of 93 billion light years? If an object created shortly after the Big Bang traveled at the speed of light, it should have traveled a maximum of 13.7 billion light years by now. Nothing more, nothing less. Where did all the matter beyond this point come from? This is where Hubble's law comes into play. According to the law, objects observed in deep space are redshifted. The term redshift refers to a shift in the wavelength of light from the blue to the red end of the spectrum, or an increase in wavelength. However, why does the wavelength lengthen? One reason is that the universe is expanding. Not only are objects moving away from one another, but the fabric of space is expanding as well. This is where things get crazy. The expansion is speeding up. Dark matter and dark energy are thought to play a significant role in this behavior. As a result, when calculating the width of the universe, the extra distance due to the space expansions must be factored in. This is why the universe's edge is clearly not 13 billion light years away from Earth. It's thought to be much higher than that. What is the farthest astronomical object visible to humans? One thing to keep in mind is that some objects in the universe may never be seen. Why? Earth is about 16 billion light years away. This is the universe's current cosmic event horizon. Are we close to our destinations? No. Not at this time. If light originated at that distance today, this is the farthest it could ever travel to reach us. This means that the expansion of space is faster than the speed of light, beyond 16 billion light years. The light will obviously never reach us because it will have to travel through an expanding space. This also means that any event that occurs beyond the cosmic event horizon today will not be visible to us no matter what. But thanks to the telescope like the JWST, we can see even further. The GNZ11 galaxy, which is about 32 billion light years away from Earth, is the most distant galaxy ever discovered. Remember, we factor in the expansions of space when calculating this distance. We reach the surface of last scattering, which is about 46 billion light years away from Earth. This is what you will notice regardless of which direction you look. After recombinations and photon decoupling, the surface of last scattering looks like a uniform space, a fog, from which the first ever photons of cosmic microwave background radiations emerge. It is the origin of the very first scattering of light, but the last of what we can observe despite the name. Is this at long last the universe's edge? There's a yes and no. This is the farthest point in space and time that we can observe from a technical standpoint. This is essentially the observable universe edge. What is known as the opaque universe is what lies beyond that. This is the boundary between what we can see and what we can imagine. Let us now venture even further beyond the observable universe's edge. What could possibly exist there? We've only ever looked at what existed at a specific point in space in the distant past. What could possibly exist there right now is a more unimaginable question. The particle horizon, or the maximum distance one can see into the past, is located at the edge of the observable universe. Everything we've seen so far has been done so with Earth at the center and time scaled backwards with distance. This raises the questions whether the universe is infinite. According to Einstein's theory of relativity, a flat universe must be infinite. We can then conclude that the universe has no beginning or end. It is not an easy task. We haven't been able to definitely determine whether the universe is infinite or not. One thing is certain, James Webb will undoubtedly discover something terrifying and incredible that will astound the entire world, and we will one day question our very existence. Let us know your thoughts on James Webb Telescope in the comment sections. And that's all for today. Thank you for watching the video. If you enjoyed it, then please make sure to like, share, and subscribe to our channel for more such exciting videos like this one.